Hi everyone, welcome back to another video. In this video, we're going to learn Kubernetes pods, both theory and demonstration. So if you're wondering what are the things that we will be covering, so in this video, we are going to learn what is a pod, how to create pods using CLI and YAML, how to access the documentation related to a pod specification, right? So how do you execute a command in a running pod? What are pod restart policies? Basically, you have default value and what are the available options if you want to change them. And what is the difference between declarative and imperative approaches when using kubectl? How pods make use of the network namespaces for the shared IP address? How pods are able to communicate without the use of NAT or other complicated network setups? We will also see how to run multiple containers in a single pod, how to access logs from a particular container when running multiple containers in a pod, and we will also see how to access logs from a terminated container in a pod when running multiple containers. And at the end, we will also discuss what are sidecars and how it could be implemented. So now coming back to our question, what is a pod? If you're thinking that I'm going to present you for the entire demonstration, no, we are going to cover the demonstration as well. So wait for a while for me to explain what is pod. Basically, in all the interviews, when we ask what is pod, the typical answer that we get is the smallest unit of the compute. What is this smallest unit of compute and why do we need this pod exactly? Basically, pods are required to run one or more containers. Typically, it will be one container, but there are scenarios where you will be using multiple containers. For example, if you ask me, let's say I have a main container and I'll run a sidecar, a side container, which will check the health status of the main container. That can be one use case, right? So that is why a pod is used to create one or more containers. So containers, these containers that we are talking about will share the networking provided by the pod and will communicate using the local host, right? Each pod is assigned with a unique IP address within the cluster. We will see this in action in the next section where we will be creating a pod and you will see exactly the pod is getting assigned with an IP address. Containers in the pod can communicate with each other using inter-process communication. Let's say you have one container, right? And there is another container. If you ask me, are they able to communicate with each other? The answer is absolutely yes, because we have something called as inter-process communication. We will also see this in the demonstration. Wait for a second. Basically, if you are thinking, what is this pod and why do we need this pod? A pod can encapsulate as in cover all these things. Basically, what are the things we are going to cover? An application, its dependencies, shared storage, and networking into a single deployable unit. I hope that makes clear to you regarding what is a pod. Now, without wasting much time, as I mentioned, the 12 points that we have mentioned in the beginning of this video, we will go through them one by one in the live demonstration right now. See you in the shell. All right, this demonstration relates to the course section on Kubernetes pods. So I recommend you to either view the video first or watch the video while working through this lab, right? So let's use the Nginx web server to run a simple pod with a single Nginx container. So to do that, we will run a command called kubectl run nginx -- image nginx. Let me break this down to you. So here kubectl is the command line tool, and here we are running nginx pod. We are creating a pod with the name nginx, and we are using an image called nginx. So if I hit run or if I hit enter, you should be seeing this, a pod named nginx is created. So now let's query our running pods using kubectl get pods. So if I break this command to you, we are getting all the pods that are running inside this cluster. So if I hit enter, you will see we only have one container, or sorry, one pod, that is Nginx, and the status is running. Now let's say you want to see the logs for this particular pod. So if, let's say you want to verify a few things, what are all the things that have happened in the background, you want to verify them, you can run this kubectl logs pod/nginx. So if you hit enter, you will see all the detailed log for this particular pod. Okay, now let me just clear the screen to you. And let's say if you query our running pods with the -o option, we will get more information including its IP address. So let's give it a try. So the command for that is kubectl get pods -o wide. Basically, we are getting more information about all the pods that are running. If I hit enter, previously we used kubectl get pods, but it showed only the status and the age. But here, if you see, we are also getting the IP address where this particular pod is running. It's running on worker node 1 and other details, right? So this is the use of kubectl get pods -o wide. Now let's say if you want to check this IP address is pingable from our control plane or not. If you see here, I'm in the control plane now. For the ease of this demonstration, I've created 2 worker nodes along with 1 container plane. Control plane, sorry. So if I run ping and I say this IP address, so if you see here, I'm able to ping this IP address being inside the control plane. That is what we studied in our the theory part, that the pods or the containers inside this cluster will be able to communicate with each other with something known as inter-process communication. So let's not stop it here. Let me clear the screen. Let's say I want to run this on the worker node 1, because if you see here, let me run kubectl get pods. If you see here, let me go with -o wide, and if you see here, it's running on worker node 1. So let's change it to worker node 2. Let's SSH into worker node 2 and see if we are able to ping this IP address or not, right? So let me grab the IP address, let me paste it here, SSH worker node ping, and I'm using -c with 3 pings. And the IP address is this. If I hit enter, you should be able to see that we are able to ping this particular IP address being in the worker node 2, although the pod itself is running on the worker node 1, right? So that is the use of it. Okay. Now let's talk about another thing. Let's explore an alternative approach where we will run a pod with Ubuntu. Just this Ubuntu will just runs with sleep infinity command as soon as the pod is created. So we will also pass the variable for our Nginx IP pod so that it's accessible as an environment variable within the pod and so on, right? So to do that, first what I'll do, I'll create an let's say I'll create environment variable called Nginx _IP, and I'll say kubectl get pods, and I'll just use the AWK command to get the IP address, and I'll store it inside this particular environment variable. So if you see here, I got this. Even now, what you can do is, instead of trying this, instead of copying pasting this IP address every time, if you want to use this IP address in any other pods, you can just get the environment variable in action, right? So that is what I was talking about. Okay, now let's do one thing. Let's go ahead and create another pod. As I mentioned, we will go ahead and create the Ubuntu pod while we ask the Ubuntu to run sleep infinity as soon as it gets created. Okay, to run the same, you just follow the same command, that is kubectl run --image is Ubuntu, and the name of the pod is Ubuntu, and here I'm giving the environmental variable Nginx IP as the Nginx IP, and as soon as the pod is created, I'm asking it to run sleep infinity. Now let me hit enter. If you see here, Ubuntu pod is created. So if you want to verify, what will you do? Let me know in the comment section. So you'll just run kubectl get pods -o void command. And if you see here, we have two containers. That is one is Nginx, which is running from 5 minutes, and Ubuntu is the latest one, which is running since last 30 seconds. And if you see, it's Nginx is running on worker node 1, and whereas Ubuntu is running on worker node 2. Now let's say you want to execute a command being inside this Ubuntu container or pod. What will you do? So we have a command called kubectl exec. So let me write the command for you first and I'll explain it. If you see here, kubectl is same as it is. Exec means execute a command in an interactive mode on the pod Ubuntu. What is if you want to interact with a pod like Ubuntu, you will go with a bash. So if I hit enter, I'll be inside this Ubuntu pod. If you see here, this is the Ubuntu, and if you see here, this is a control plane. Now let's say I'll just type in who am I, and I will see root, right? So this is another example. Let me just go ahead and exit out of the Ubuntu container. So this is how you run or execute a command in Ubuntu pod. So now if you are wondering how to delete the pods, so to do that, you will have to run this command called kubectl delete pod with a pod name. So let's say you have a pod with Nginx with the name Nginx, and you also have a pod named Ubuntu. If you see here, these are the two pods that we have. So I'll go ahead and use those things, and I'll just mention hyphen now, basically asking Kubernetes to delete the pods right away. So if I hit enter, if you see here, you should get a response saying pod Nginx deleted and pod Ubuntu also deleted. All right, let me clear the screen for you, and we will see another alternative approach to create the Kubernetes pods. So let's say we can also use kubectl options of -o yaml along with --dry-run is equal to client to show the YAML declaration of the CLI that we are trying to use. Basically, we are using kubectl run Nginx CLI command, right? So behind the scenes, what it will do, the command that you are running will be converted into a YAML file, and it will be sent, it will be called as a manifest file, and it will be sent to the cluster to create the pods. So we can also create pods or any other services under Kubernetes using this particular file or a YAML file. So let's also see how we can do that. So we have this command. If you see here, we are exactly running the same command, kubectl run Nginx, and we are using Nginx image. And basically, I'm just mentioning -dry-run is equal to client -YAML, because this will be a YAML file in the backend. So, and I'm using t command to create a file called nginx.yaml. Basically, I'm simulating this command, as it will not create the resource, although it is going to give us the output. So, and also this, the output will be appended into this file called nginx.yaml. So you can use that file to create Kubernetes pods as well. So let's hit enter and see what are the things that we get as part of this. If you see here, these are the mandate fields that we need to fill while creating a pod using Kubernetes YAML manifesto file. So we need to mention the API version. As we are running the command, CLI command, it is using the default values. If you see here, it is using API version as v1, and the kind is pod. So basically we are creating a pod, so that is why it is taking pod. And metadata creation timestamp run is Nginx. The name of the pod is Nginx, and these are the specifications under specs. We have containers. Basically, what is the container that you are using? We have a container image, that is the name of the image is Nginx, and DNS policy is cluster first. Restart policy is always. So now, what is this restart policy? Why do we need this restart policy, right? So basically, if you wish to know more on this particular section of Kubernetes YAML, you can use the kubectl explain command to get more information. For example, let's say we do not know what is this restart policy. What you can do is you can just run kubectl explain and pod. Why am I getting pod? Pod is because the kind is pod, and then under pod we are going in spec, and under spec we have something called as restart policy. So pod.spec.restart policy. If I hit enter, you should be able to get the description of that particular thing that we are using. If you see here, it will give you the entire description. We have restart policy for all containers within the pod, one of always, on, failure, and never. So if you can either use always, on, failure, or never. So here by default it is going to be always. You can also set it to on, failure, and never. Basically the pod will be restarted always when you create a cluster or restart the pod. And on failure means whenever there is a failure pod for this failure observed on this particular pod, a new pod will be created automatically for you. And never means it will never create a pod even though the pod gets failed. So that is the these are the possible enum values that you can append for this cluster restart policy. And this is not only for this. If you want to use if you want to learn more on let's say what is run, right? So you can go ahead with just type a command called kubectl explain pod dot metadata and run. That's all. You will be able to get more details on that. I hope I'm clear on this. Now let me go ahead and clear the screen for you. Now, as you already know, we have a file called nginx.yaml, right? So that is what we created by simulating the command by using that command that we already saw. So now let's say I want to create the nginx pod. So how do I do that? So for that you can use something called as kubectl create -f and the name of the file. -f is used to specify the file name. So kubectl create, the file name is nginx.yaml. That is the meaning of this command. Now if I hit enter, nginx pod will be created. Right? So that is the beauty of this. If you will have the manifest file with you, and you will just go ahead and apply or create the command. An alternative approach is to use the declarative approach. So if you do not know what is this imperative and declarative approach, now let's talk about that. So imperative commands. So imperative commands include create, replace, or delete. Basically in Kubernetes, imperative commands are the way you interact with a cluster by directly instructing it to perform specific actions. Let's say there is a cluster and you ask the cluster, hey cluster, I want to create the pod. So if you do that, that is called as imperative operation or imperative commands. So these commands focuses on desired outcome rather than the underlying configuration files or the declarative state. When using imperative commands, you provide explicit instructions to create, replace, or delete. While imperative commands can be convenient, they may result in configuration drift if not carefully managed, as the desired state is not explicitly defined and tracked. So that is the disadvantage of using imperative commands. Now let's talk about declarative approach, that is apply. In Kubernetes, declarative commands are preferred approach for managing the cluster state and resources. With declarative commands, you define the desired state of your Kubernetes objects using a YAML or JSON configuration. Rather than specifying individual operations, you provide a compute representation of a desired state of your resources. When applying these files, Kubernetes compares the desired state with the current state of the cluster and automatically performs the necessary operations to reconcile any differences. I hope that is clear what is the difference between imperative commands and the declarative commands in Kubernetes. Okay, after understanding what is imperative and declarative approach of creating the pods, Now we are going to apply what is this entity should look like, and you should get a warning initially if you do this on an entity that is already created. Basically, we already have Nginx pod that is created, but if I run this again by going with kubectl apply -f and nginx.yaml, you will get a warning message. Let's see that. If you see, we are getting a warning message. Basically, it's saying pod nginx is already configured. Now let's say if I run the same command again, I should be able to create the container now, or the pod. So I'll create another one. I'll create another one. I should be able to create multiple pods, right? So that's the beauty of apply and create command in Kubernetes pods. So now let's do one thing. Let me clear the screen, and let's try to create another pod. Basically, I'll go with the Ubuntu itself because that is the first example that we took. So let me do the same thing. Let me run a kubectl ran, image is Ubuntu, and I'm using dry run. I'm not creating the resource, but it is just a simulation of this command. Basically, it will give me the output in a YAML file, and I'm saving that YAML file as ubuntu.yaml. Okay, now let me hit enter. If you see here, this is the contents of the file. As I mentioned, restart policy will be always by default. Now you should be knowing how to create the Ubuntu pod. So let me know in the comments how to create the Ubuntu pod. So it is as simple as that. You will either go ahead and kubectl create -f ubuntu.yaml, or you will go with kubectl apply -f ubuntu.yaml. If I hit run, you should be able to see the Ubuntu pod that will be created for you. Now let's go ahead and verify how many pods we have now. So if I hit enter, you should see kubectl get pods -o wide. So if you see here, we only have 2 pods that are running, that is Nginx, and the other one is Ubuntu, right? So this is how you create the Kubernetes pods using CLI, that is kubectl run command, and the YAML file either by using create and apply command. Now let's see how to delete these pods. So I'll just use the same command, that is kubectl delete pod name, and I'll just give -, now to just delete it right away. So if I hit enter, you should be seeing this message called pods are deleted. Now let me clear the screen for you. Let's see another example of creating this. So currently we have 2 separate files, right? Let me run ls-lrt. If you see here, we have a manifest file for nginx.yaml, and we also have another file called ubuntu.yaml. Basically, those will create their respective pods. So what we will do, currently we have 2 separate files, but a YAML file can contain multiple declarations. Say in a nginx.yaml file, if I go and append my ubuntu.yaml, it should be able to take that as a good YAML file. So we will use 3 hyphens to separate the YAML. So that is what I meant to say. So we will use this T to save this into combined.yaml. So what I'm gonna do is, so this is what I meant. So first we are seeing what we have in nginx.yaml, and we will add a separator for this file. So in nginx.yaml, what we are picking the contents of nginx.yaml, and we are adding 3 hyphens. Basically, that is the YAML separator, and we are also taking the contents of ubuntu.yaml. And after taking that, we are going to create a new YAML file called combine.yaml. So this YAML file will contain both the manifest file or the YAML file for Nginx and Ubuntu. So if I hit enter, if you see here, this is the nginx.yaml, and this is ubuntu.yaml. So that's the beauty of it. So now if I just go ahead and clear the screen for you, and if I run kubectl apply -f and combine.yaml, and if I hit enter, you will see 2 pods are getting created for you. So how do you verify that? You already know the command kubectl get pods -o wide. So if I hit enter, I should be able to see two pods that are created at the same time and having two different IP addresses, because these are two different pods and the containers inside the pods will have two different IP addresses. Now let's do one thing. Let's modify the combine.yaml file so that we are running a single pod with two containers. So let's try to move the Ubuntu containers section into the Nginx section itself. So the Ubuntu container will be configured as a sidecar. So that is what I was talking about. Sidecar, imagine a sidecar like this, a scooter with another part getting added. I'll add a screenshot for your reference in the left hand side. So that's what a sidecar is. And that echoes the log and exits if a file called /temp/trash exists. Basically, the sidecar will monitor all the time. And if a file called crash exists, it will stop the logs, right? So it will get restarted. So we will also update the metadata to match, and we will use the following command. So this is the command that I was talking about. If you see here, we are just opening this command.yaml, and what we are doing is we are just moving the Ubuntu section in the combine.yaml, and we are adding in the container section directly. Instead of creating two pods, what we are doing, we are moving Ubuntu section under containers itself, so that this pod will contains two containers at the same time. Okay, if I hit enter, this file will be appended, right? So the changes that we made to the file will be took place. Now what we'll do, we'll apply this new combine.yaml file and see what happens. If you see here, you already know the answer, how to create the pod. kubectl apply -f combine.yaml. If I hit enter, you only see a pod called my pod getting created, because I've changed the name of the pods here. But previously what happened, if I ran the combine.yaml, we saw two pods are getting created. Now we only see one pod. The reason is simple. We are trying to have two containers in a single pod, right? So that's what it is. Now let's say we want to, using kubectl, we can also describe the pod for further information. In particular, the IP address and each of the containers, let's say name, web servers and the sidecar. So to do that, you can just run kubectl describe and the pod name. So if you see here, you get all the information related to that. You can also see the events that happen in the backend. It pulled the image, it successfully pulled and created the web server, and it started the web server, and later it pulled another image called Ubuntu, and it created the container, and that container is named as sidecar, and it started the container with a sidecar. So all these details will be present in, if you want to get more information, you can just run kubectl describe and the pod name. Let me clear the screen for you. Now let's capture the pod IP address. So to do that, I'll just use the environment variables, or you can just run kubectl get pods -o wide, and you will see the IP address of the pod as well. That is another thing. I'll just hit enter and I should get the IP address associated. So this is the IP address that I was talking about. Now let's check that this is accessible using a throwaway curl pod, or you can also use another pod to check this, right? But we are not going to do that, because as you already saw in the demonstration, one container or a pod will be accessible, will be able to communicate with other pods because of this inter-process communication, or IPC. Now let's check if the logs for this side container are present, and we'll see if it is working as expected. So how do you check the logs? You already know that in the beginning of the video itself I mentioned that is by running kubectl logs the pod name. But here we have two containers in a single pod. How do you check that? So to do that, you mention -c and the name of the container, right? So the container name was sidecar, and if I hit enter, you should be seeing the container logs, because this is what I configured in the combine.yaml, right? So and if we check the sidecars logs, we will see all the details, right? So now let's remove the pod. Let's go ahead and just run kubectl delete pod, and we'll give the hyphen now. And if you see, the pod named my pod is deleted automatically. So these are all the things that you want to know as a basic thing if you want to learn about what are pods and what is the use of it and how to create pods in different ways. I hope I have summarized everything in a single video. I hope this is helpful. Please let me know in the comment section if I want to create more videos like this. I know if I've made any mistakes, please apologize for that. It was not it was unintended. I am recording this in a single shot. I'm not taking any breaks or anything, right? So with that being said, that is what I wanted to cover in this video. If you're liking the content that I'm creating, please like the video, subscribe to the channel, and share it among your friends. Thank you, and I will see you in the next one.